Hi folks, so this is the Leaving Cert Higher Level Maths Paper 1 for 2021. So the first question is complex numbers. So we have to make that fraction look like this, 0 plus ki. So whenever you have a fraction with complex numbers, it's really giving you the hint that you need to multiply by top and bottom by the conjugate of the bottom. So 4 minus 2i over 2 plus 4i. So the conjugate of the bottom there, the 2 plus 4i, would be 2 minus 4i. So you must multiply top and bottom by 2 minus 4i. So that's the same thing then as multiplying by 1, because anything over itself is 1. 2 minus 4i over 2 minus 4i is 1. So you're multiplying out kind of double brackets on top and bottom. So you could go off and you could do it in the table. So you could do 4 and minus 2i, and then 2 and minus 4i. You might have learned how to multiply double brackets that way, or you might just have learned to just multiply everything by everything, or do these arrow things. But either way you should get, so 4 times 2 is 8, 4 times minus 4i is minus 16i, minus 2i times 2 is minus 4i, and minus 2i times minus 4i will be plus 8i squared. All over then, 2 times 2 is 4, 2 times minus 4i is minus 8i, plus 4i times 2i is plus 8i, and 4i times minus 4i is minus 16i squared. Now the thing about complex numbers, and it tells you up here in the question, is that I squared will always be the same thing as minus 1. So we don't need to go into that, why that is too much, but anywhere you see an I squared, so here and here, you can replace both of those with a minus 1. So I'm going to write out the same thing again, but so 8 minus 16i minus 4i, and then if you think about it, 8 times minus 1 on top will just be minus 8. On the bottom then you get 4 minus 8i plus 8i, those two will just cancel out, and then minus 16, and you're timesing it by minus 1 because I squared is minus 1. Minus 16 times minus 1 is plus 16. So we get 4 plus 16 on the bottom. And then if you just so on the bottom you're going to get 20. On the top you're going to get 8 minus 8, which is just 0. And minus 16 minus 4i would be minus 20i. Divide both of them by 20. 0 divided by 20 is 0. And minus 20i divided by 20 is just minus 1i, or just minus I. So the question asked us, the answer to it is 0 plus ki. So what does k have to be then? K is just the thing that's in front of the I. So it'll just be the minus 1 part. So k is minus 1. And that's the answer to the first part. So part A. Part B then, you have to find this and give your answer in the form of a plus bi. So we could just let it equal to a plus bi. So root minus 5 plus 12i. Let it be equal to a plus bi. Now to get rid of the root then, you can square both sides. So on the left hand side you're just left with minus 5 plus 12i. On the right hand side you're squaring out a plus bi. So again you're going to get double brackets and you're going to square them. So you should be left with a squared plus abi plus abi. So that's 2abi. And then that's plus b squared I squared. Okay, so that should be 12. Remember again, you got an I squared here, so you can replace that with minus 1. So minus 1 times b squared would be minus b squared. Now we're going to let the things that are we're going to let the real parts be equal and the imaginary parts be equal. So the real part on the left hand side is the minus 5, and on the right hand side it's the a squared and it's the minus b squared. So they're all free from an I at the end of them. So they don't have, none of those things I've underlined have an I stuck on the end of them. So therefore they have to be equal. So minus 5 is equal to a squared minus b squared. Let the imaginary parts be equal then. The plus the positive 12 there has to be equal to 2ab because they both have the I on the ends. They're the imaginary parts. So 2ab is equal to 12. Therefore ab is equal to 6. And then we've kind of got two equations then with two variables. So easiest way to solve, maybe we can let a be equal to 6 over b, like that. So let a be equal to 6 over b. So if I take this equation then and put in that, so I'm going to write it over here. Minus 5 is equal to 6 over b, and we have to square that, minus b squared. So that would be minus 5 is equal to 36 over b squared minus b squared. Let's multiply everything by b squared then, just to get rid of the b squared on the bottom. So we get minus 5b squared is equal to 36 minus b4. Move everything over to the left hand side, we get b4 minus 5 b squared minus 36 is equal to 0. So we have a quadratic then with b squared as the variable. So it'll be b squared and b squared, so I'm factorising them. So two numbers that multiply to give minus 36 but add to give minus 5, it'll be minus 9 and plus 4. Minus 9 times 4 is minus 36, minus 9 plus 4 is minus 5. Therefore b squared is equal to, well, b squared minus 9 is equal to 0. We'll just do it all out. Or b squared plus 4 is equal to 0. So b squared is equal to minus 4, or b squared is equal to 9. If b squared is equal to 9, well then b has to be equal to either plus or minus 3. It could be either of them. Now the other part, it says that b squared is equal to minus 4. So b squared can't be equal to minus 4. Therefore we can't have that. So b is plus or minus 3. Now remember this equation here, we had a is equal to 6 over b. So you can sub back into that then. So if b equals 3 and if b equals minus 3. If b is 3, well then a is 6 over 3, so that's 2. If b is minus 3, well then a equals 6 over minus 3, and that's minus 2. So our two answers then would be, so for the first one, it would be 2 plus 3i. I'm just putting it into the form a plus bi then. And the second one would be minus 2 minus 3i. So there are two answers. Right, so for part C then we have to put this, so z cubed equal to minus 8. We have to find the 3 roots of it. So we're going to put it into the Myers theorem. It tells us to do the Myers theorem anyway. So if we were to draw out what that would look like, that's the same thing as minus 8 plus 0i. Okay, so it doesn't really have an imaginary part. So if you were to draw that out, minus 8 is out here, and plus 0i, so we go across to minus 8, put it out a bit further actually. So we'll just say that's minus 8 plus 0i. So r cos theta plus I sine theta, that's the general form of the Myers theorem. R has to be the distance out to the point, so it's just from the origin out, so that's just going to be 8. And so this is what Z will look like then. 8 cos, and then our angle is just going to be around to here, so that's just going to be pi, because pi is always around to there, plus I sine of pi. Right, so we should have had Z cubed there actually. So Z then, it's going to be the cube root of all this, so it'll be 8 times cos of, and then we must put in plus 2n pi as well, because it could be another rotation around. So plus I sine pi plus 2n pi, and that will be all then to the power of 1 over 3, because we're bringing across that cubes then, because we want to know what Z is. So the cube root of 8 would be 2, so you can put that in there, and then the Myers theorem allows us to put the 1 over 3 in kind of just in here and in front, so multiplying by what this cos is and what the sine is. So we put the 1 over 3 in there, so cos, and then if you multiply 1 over 3 by both of these things, you get pi over 3 plus 2n pi over 3. Plus then I sine pi over 3 plus 2n pi over 3. Right, so if n equals 0, then if you just put a 0 in for n, you're just going to get 2 cos of pi over 3, and that's it really, isn't it? Because everything else cancels out in the bracket, plus I sine pi over 3 as well. And that's going to be 2 times a half plus I root 3 over 2. So we get 1 plus I root 3. Right, so that's what our first answer will be. But n might not be 0, so if n equals 1, then let's put it all in again with 1, so we get 2 cos of pi over 3 plus 2 pi over 3 plus I sine, and it'll be the same thing again, pi over 3 plus 2 pi over 3. So inside the brackets there, pi over 3 plus 2 pi over 3 will just be 3 pi over 3. So that's going to end up being pi. So we have 2 cos pi plus I sine pi. I don't know why I'm writing this in red, by the way. I only meant to write the top bit in red. But we should get 2 times minus 1 plus I times 0. So that then is minus 2 plus 0i. Third answer then, if n is 2. So if n is 2, so we're going to put it all in again. So 2 cos of pi over 3, and it'll be plus, well, 2 times 2 then will be 4, so plus 4 pi over 3 plus I sine pi over 3 plus 4 pi over 3. So that's 2 cos of 5 pi over 3 plus I sine 5 pi over 3. So cos of 5 pi over 3, we should get a half. So that's all the way around in the fourth quadrant then. So cos of pi over 3 will just be a half, and it's positive there. And then plus I sine then will be negative in there, so it will be negative in the, let's see, yeah, it'll be negative in the fourth quadrant. So therefore it's I times minus, and then sine of pi over 3 is just root 3 over 2. So we get 2 minus the 2 times the 2 on the bottom cancels, so 2 minus root 3, I root 3, sorry. So that's our third answer then. So those are our 3 roots. Actually, sorry, I multiplied this wrong, didn't I? 2 times a half is 1. Yep, so 1 minus I root 3. So that's 1 root, that's another root, and our first one was back here, that's when n was 0. So that's all for that question then.